the second derivative to be equal to 0. So first you have to find it. So here it is right here. Second derivative, and then you set it equal to 0. And then you realize it's not going to factor nicely. And it does, you know me, you've heard me say this. Everything is factorable. So it's not that it doesn't factor what? Nicely. So you need to use your calculator to figure out those errors, or use the quadratic equation and type it in. So find all the points of inflection. So here's the thing. There's one thing that's missing here. I want you to make this number line. So if you solve that quadratic, you end up with what? Negative 2.1 and 1.4. You know that those are the x. If those are the x values, what's the double prime? So they call this one g, right? Yeah. G double prime of x. So the second derivative of each of these values is 0. What did I want you to do? You also have to test what, everybody?
Well, on the outsides too.
And the outsides and the inside. Exactly. How many regions are there? 3. So I want you to test each of these. It is possible for the second derivative to be 0 and the concavity not to change. It is possible. So what you need to do is you need to test these regions. So let's just talk about the 3 good numbers. What's between negative 2.1 and 1.4?
0.
So test 0. What's to the right of 1.4? 2. And what's to the left here?
Negative 3.
Negative 3. So test those numbers and you plug it into the which derivative? The second derivative. You plug them into the second derivative. Exactly. So in this case, I'll just tell you it's going to be positive, negative, positive. So are these points of inflection?
Yes.
They occur at negative 2.1 and 1.4, but what does it actually want you to find? We haven't found the what?
The y value.
The y values. So what do you do to find the y values?
Put those into the,
You plug these into what?
do you plug into the regular?
You plug them into g of x. You plug them into the original equation. This is a good transition question for us. Second trace, it's calc, and then which one do you do? 0. What's it asking me for? It's asking me for the... So let's do the one on the right. You go to the left of where you think the 0 is. It doesn't need to be that close, but I'm going to click enter, and then you go to it asks you for the right bound. So go to the right, enter, and then what? Put it where you think the guess is, press enter, and there's your first value, 1.4305009. And then you do the same thing for the other one. I would like you to do it this way. This is, I think, the best way that is least likely for you to run into typos. I like this. Those are going to be at what? Negative 5. Where else? Negative 2 and what? 3. So we know that the graph passes through those points. That's really important to have. What does it tell us about the derivative? It tells us it's positive a certain place. The derivative is going to be positive all the way to where? To what? To negative 3. So all the way up to negative 3, what is this thing doing? It's rising. It's rising to negative 3. So all the way to, I'll do this here, all the way to negative 3, it's rising. And then what is it doing? It's then falling to where? To 1. I'm not drawing the graph yet. I'm just showing. So we know for these x values, the function, whatever it is, it'll be rising for these x values, and then what it'll be doing? It'll be falling, and then what does it do right after that? It keeps rising, right? So we know it's going to rise. And what is the derivative at each of these? What's right here? What number is right here and here? 0. So we know that there's going to be what's going to happen right there and what's going to happen right here? There's going to be what? A max and then a what? A min. So it's going to rise, fall, right? We know that's going to rise and then fall. But now we have to talk about concavity. Let's talk about concavity now. What did we like? Concave up is to the right of what? What number is that? That's 1 right there? No, it is negative 1. You're absolutely right. So we know it's going to be concave up for this region. And where's it going to be concave down? The left, right? So we know a lot. So this is concave up. No, that's concave what? Sorry.
Down.
Thank you. Concave down. This is concave what? Up. And this is rising, rising, and falling. I love using the color. Now we can actually try to sketch this. So let's just take a look and see if it matches. So if it's rising, you see those red dots? It has to cross through those dots. So let's do this. It's going to be concave down, but it's rising. with your hand, concave down but rising. What's that going to look like? Concave down but rising, it's going to look like this, right? This is concave down and rising. So that first section, what's it going to do? It's going to go up, and it's going to hit 0, and then what does it turn into? It's concave, it's still concave down, right? It's going to go, and it also has to hit that point, right? So it's going to go concave down like this, right? Are we still there? It's still concave down? So it's still concave down to here, but then what happens right here? There's a change in what? Yeah, there's an inflection point, right? So here, what does it turn into? It turns into what? So it's going down, and now it's going to go? Yeah, so you see how I wanted it to go up right there? It doesn't have to. It's going to go down, and then it's going to go up, right? Like this. Oh, but wait, where's the derivative 0? It's right there, right? Does everybody see that? Yeah. So that's where the derivative is 0. So when I do this, it's going to go maybe not this high. Does it tell us how high it has to go? No. So how high can we make it? Whatever we want it to be, right? So we go, let's say we go up and then down like that. Oh, but the 0's not in the right place, is it? Do you see where that 0 is supposed to be? Oh, 1, -3 right there. So where is this? It's going to go up to there, or like that. And it's still, oh, there we go. Nice. And then what happens here? It's rising and concave what? It's rising and concave up. So it goes up like this. There it is. Does that match? Let's check. Let's see if that matches.